Good morning, everyone. Happy Friday. So today's lesson is going to be a pretty short one. Just wanted to do one more day of practicing using the laws of sines and cosines. On Monday, we'll start doing some problems with parallelograms, forces problems, problems that requires that you know how to use the law of cosines. And also that will help us when we get to the unit later on vectors. So to begin with, let's look at the first problem. So you're given triangle ABC. Angle B is 25 degrees. A is 7 feet. C is 13 feet. And I'm asking you to find B to the nearest hundredth of a feet. So notice when I did this, because I am looking for B, I know that I start off with B squared. And because the same letter starts and ends the same, I start with side B, and I am going to end up with angle B. So if you look at the rest of the diagram, this is what I did. I plugged in, again, remember the law of cosines. It's basically working with any two sides and the angle in between. So I've got 7 squared plus 13 squared minus 2 times 7 times 13 times the cosine of 25 degrees. I put this entire thing in my calculator, and I am going to end up with 7.28 feet. So that's for the first part, using the law of cosines. Remember we had said that even if we wanted to use the law of sines, I can't, because the law of sines means that I would need to know two angles in addition to two sides, and I don't have that. But now that I found out that B is 7.28 feet, what I'm going to do is ask you to find the measure of angle C. Because I have the 7.28, it's going to make it just a little bit easier. So here's what I did. I plug in the information, making sure that I put in the 7.28 here. So now I look, and if I'm looking for angle C, I've got side C that goes with the angle C. I have angle B, and now the side B that went with the angle B. So my proportion is 7.28 over sine of 25 degrees equals to 13 over the sine of C. I cross multiply, do the math. I get that the arc sine of C is 13 times sine of 25 degrees divided by 7.28. And when I did that, I got 79 degrees. Please do this along with me, just to make sure that you're getting the same numbers that I'm getting. So now I want to look at what problem 2 looks like. Again, number 2, it's a lot of stuff in here. So let's just let you get this part down. How's that? So a hiking trail. Oh, let me just do one thing. Let me get rid of this guy. There we go. A hiking trail is planned in the shape of a triangle with size 2.3 miles, 8.1 miles, and 6.2 miles. I want to find to the nearest tenth of a degree the angle between the 2.3 mile side and the 6.2 mile side. So the first thing you should do is draw for yourself a triangle, and just go ahead and put in those sides. So here's what I did. I did my triangle, and I just put in 2.3, 6.2, 8.1. The angle between the 2.3 and the 6.2. So it's this angle right over here. So while here there's no ABCs to use, I notice that if I'm looking for this angle, I am working with this side. So I can fill this in the same way. So it's 8.1 squared is equal to 6.2 squared plus 2.3 squared minus 2 times 6.2 times 2.3 times the cosine of x. So if you look at this entire substitution, this is different than what we did previously because I'm looking for the cosine, the angle itself, x, and not so much the side. So I just do each part individually. The 8.1 squared, the 6.2 squared, the 2.3 squared, the negative 2 times 6.2 times 2.3. Once I have all of that, remember I can only combine like terms. So when I add 5.29, 38.44, I get 43.73. The negative 28.52 cosine x is still here. They're still not like terms. So now I'm going to keep this guy last. Subtract 43.73 on both sides. I get 21.88 equals the negative 28.52 cosine of x. To get cosine of x, I divide by negative 28.52. So right here. Oh, by the way, it's not drawn to scale because I don't know that it's an acute and obtuse, whatever. Obviously, the sides are not the same. It looks here like it's equilateral here. So when you draw a triangle, just keep in mind, it doesn't have to be drawn to scale. All right, so I go to this. Now, the other day, we did a problem where they were both negative. So cosine came out to be positive. So we end up with an angle in quadrant 1. This is negative. It's like solving for equations. If this is negative, cosine is negative in quadrants 2 and 3. Quadrant 3 goes from 180 to 270. That's too big for my triangle. But then that means the angle here has to be an angle in quadrant 2. So here's what we do. Again, what I said to you before, that cosine is negative in quadrants 2 and 3, but since the angles of a triangle only adds up to 180, we only look at the quadrant 2 angle. So I put this in, but just like solving trig equations, I put in the arc cosine of just the positive value, because then this gives me the reference angle. And in quadrant 2, it's 180 degrees minus reference angle. So my answer is the angle x is 140.1 degrees. So if this was drawn to scale, this would be an obtuse triangle. Right here, this would be 100.1 degrees. There's one more thing we haven't done yet related to the law of sines and cosines next, and that is this. We haven't done the area for a triangle yet. We've done it for right triangles, right? It's 1/2 a base times height. Here it's 1/2 AB sine C. So it's 1/2 any two sides and the angle in between. This is the generic formula that we use for all triangles. So based on what I have 1/2 times 2.3 times 6.2. The angle in between was exactly what I solved for, which is 140.1 degrees. When I did all of this, this comes out to the area is equal to 4.6 square meters. So that's one new thing here. But again, this formula is the one that you use. As I said, today was going to be very short. So all you're going to do next is to work on this problem. Not giving you the triangle, but go ahead and draw in for yourself. Fill in the information. Here you're looking for the length of the third side. Here you're looking for the angle in between the smallest side and the largest side. Again, draw the picture. You'll see once you have it. And then for this problem, again, I'm not giving you any triangles. I'm giving you 3 sides. Solve the triangle. Again, what does that mean? Solve the triangle means look for the missing parts. And the missing parts here are my 3 angles. Look to see if you're able to get the same answers that I got. And if you're not able to do so, then please come on back. Oh, I'm sorry, guys. I just realized that it's 101 degrees, 24 degrees, and 55 degrees. All right, so if you're not able to get the answers I did, then you want to come over to Zoom at 12. All right, everyone. At this point, you can just go ahead and sign off. I'm just going to save this slide and wishing everyone a very happy weekend. Bye-bye.